Hi, this is Mr. Grack. We're gonna have some fun today. So, I have a new test that I've written, and I have my CPU resource monitor up right here. And the test that I've written can be run concurrently or sequentially. What I'm gonna do right now is I'm gonna run it sequentially, just using those 4 lines of code. And I'm gonna look at the core CPU usage over here. And this is also going to run the simulation 100 times, and it's going to average out how long it takes to do. So go ahead and start it up. So it looks like it's coming in at around 390 milliseconds, and it's always ending on frame 1022. It's going to take a little while for this to complete. You don't want to do anything while it's running, because you don't want to mess up the testing environment. So it looks like it took 387 milliseconds. I'll just write that down real quick. 387 milliseconds and 1022 frames on average. So it looks like we hit about 50%. There's 50%. It looks like the cores, there's 3 of them at 50%. This looks like it's under 50%, around 40%. This total CPU core usage. So the compilation is creating assembly code that the OS is then trying to schedule into threads as best it can and split that among the cores. So now we're going to comment out the imperative evaluation, and we're going to uncomment the multi-threaded solution that I set up. And let's compare the two. So let's see. The main thread is going to not be doing much. It's going to be doing some work right here. The move work is what it's doing. And then we're doing collision work on 2 separate threads. So this is more for a 3-core system, but let's see how this is handled by the CPU cores and see if we can get above, like, I want to say 40% efficiency here. CPU usage. Alright. So let's see what happens. So frame times went up a lot because work is very light in the main thread. Sim times dropped to, I want to say like 160, maybe 170, but we can see the core usage over here just skyrocket. Like we're at 100% usage. Okay, so 180 milliseconds over, geez, that's 11 million frames. And we hit, I want to say, between 90 to 100% CPU usage. Okay, and so the only difference between the work being done here is that we're putting these 2 on separate threads. That's it. And we're doing this in 1, 2, 3, 4, 5, 6, 7 lines of code. It took 7 lines of code to move this from a single threaded version that ran at 387 milliseconds to a multi-threaded version that actually hit all the CPU cores and dropped simulation times to 180 milliseconds. So I think there's merit to these ideas. That's all I'm saying. That is the only argument I'm making here. I think we can do things better. And that's literally all I want to do. So please at least consider these ideas. Thanks.